Hi, I'm Bob Szabo from AirDensityOnline.com. We're going to show you how to set up a tuning profile for a normally aspirated engine using ProCalc. The first thing we do is go into our baseline profiles. Our last exercise with this calculator was for a supercharged engine, and we have that baseline profile still loaded. So what I'm going to do is delete this so that we can start from scratch on our normally aspirated engine. I click delete and hit edit this baseline, and that will delete it, and that's starting me all at the beginning in the ProCalc. So what I want to do, we're going to assume this is a 475 cubic inch engine, and I'm going to select 475 torque peak. This is significant, and then I'm going to add baseline. Now, the second thing I have to do is set up a profile for the horsepower peak, which is different. So I'm going to, again, assume we have a 475 cubic inch engine. I pick the 475 horsepower peak, and then I'm going to add baseline. What we have now is the same engine. One is without a high-speed bypass. The second one, and that would be for the torque peak, and the second one would be with a high-speed bypass, and that would be for the horsepower peak. We're going to examine these with our air-to-fuel ratio calculator now. The first thing we're going to do is examine the combination without the high-speed bypass. That would be normally aspirated 475 torque peak. That's what defaulted, so we'll go ahead and select that. And the weather for that day is going to be 85 degrees, 25% humidity, and a 29.5 for the barometer, and that's uncorrected. So we're going to go ahead and get air-to-fuel ratio. Now that's showing a 4.75 air-to-fuel ratio. And you'll recall our baseline was about 5 to 1. It was closer to 5 to 1. So I want to lean this down from the 475. So I'm going to take my 95 and I'm going to go down to a 90. Oh, that's the wrong direction. I want to lean it down, so I want to make the go to 100. I went from 95 previously to 100. Now let's see if that gets us in the right direction. Okay, that's 5 to 1. That's pretty good. So for that weather, we've determined that we have to change our main bypass from a 95 or our baseline to a 100. What's significant here is we want to open our high speed at 5,000 RPM. This is the fuel pressure in the system before the high speed opens at 5,000 RPM. This is what I would set my high speed bypass poppet. Would be 31 psi for a 5,000 RPM opening point in this engine with that main bypass with this air-to-fuel ratio in that weather. Okay, now going over to the horsepower peak setup, we have to change to a 100. What's significant about this is the torque peak was at a volumetric efficiency of 100%. The horsepower peak is at a volumetric efficiency of 80%. What happens above the torque peak is the engine becomes less efficient, the volumetric efficiency drops off, the airflow per revolution starts dropping off, and to chase that you put in a high-speed bypass to match the air-to-fuel ratio. Again, we keep the weather the same. Go ahead and get air-to-fuel ratio. And again, we're maintaining our 5 to 1 air-to-fuel ratio. Our adjusted pressure with the high speed open is about 50 psi, and that essentially means that it was opening at about 37 and it's creeping up to about 50 psi, and we're maintaining our 5 to 1 air-to-fuel ratio. This is called flatlining. Essentially, the car or the boat is ready right out of the trailer, right off the trailer for that weather that we entered into it.